more about all this at the end of the video, but right now let's get to the video. We want to construct Pascal's triangle, which turns out to be very handy when we're doing combinatorics, when we're counting possibilities and so forth, as we'll see. Okay, well, Pascal's triangle, first of all, I've got a set of blocks here. Okay, I got 5 blocks down here. Immediately above that, I've got 4 blocks, then 3, then 2, then 1. And each set of blocks is centered along the same line. So we have kind of a line of symmetry down through the middle of this thing. This is pretty much how you would naturally stack 4 blocks on top of 5, 3 on top of 4, and so forth. Okay, well, we usually don't draw these blocks, but the blocks are going to help us understand exactly what the relationships are here. And then we'll draw the triangle again without the blocks. Okay, we start at the top block and we put the number 1 there. And then we put 1 on the leftmost block in each row, and we put 1 on the rightmost block of each row. So we have a bunch of 1s running down here, a bunch of 1s running down here. Now we want to know what numbers are going to be put into the other blocks, because we're going to put numbers in all these blocks. Okay, well, the number that goes in any block is the sum of the numbers in the 2 blocks above it. The 2 blocks it's touching above. So this block touches this block and this block with 1s, so we're going to put the sum of those numbers, which is 2. Okay, this block here, above it you have this block and this block. So you have the 1 and the 2 here. We can add those, and if I'm doing my arithmetic correctly, I believe I got that one, we get 3. Okay, this block has a 2 and a 1 in the blocks above it. So we add the 2 and the 1, we get 3. Now, go ahead and stop, pause the video a second, and fill in what you think belongs in the 3 unlabeled blocks of the last row here. Okay, well, you should have paused the video and done that. This block is touching these 2. We got a 1 and a 3, that makes 4. This block, well, the 3 and the 3 are above it, we get 6. 3 and the 1 here are going to give us 4 here. And the pattern should be clear. Now, I'm not going to draw the blocks, but I'm going to extend this a couple more positions. I'm going to put a 1 here and a 1 here, and I'm going to have a row that fills in here. Then I'm going to put a 1 here and a 1 here, excuse me, and fill a row in, and I'm going to, feeling ambitious, I'm going to go ahead and do 1 more row. Okay. The 1 here, if there was a block here, you would see there's the 1 here and no number here. So this 1 just follows from this 1. Every 1 follows from what's above it. What's going to go here? Now, if we did have a block here, it would be centered right here, and it would go like from here to here. So the number in that block is going to be right below here. So the number is going to be 1 and 4, so we're going to put a 5 right here, right halfway between the ends of these 2 blocks. Okay, so that we make a little triangle here. We have 1 and 4, and we have 5 directly below the 1 and the 4, right in between them. Okay, well, see if you can fill in the rest. You should pause and do that, and you should have already done that. So 4 and 6 is going to give us 10. The 10 is going to go right in the middle between the 4 and the 6, but in the next row. The 6 and the 4 is going to give us 10. The 4 and the 1 is going to give us 5. And then what? Well, see if you can go to the next row and see if you can fill it in. Okay, well, hopefully you paused and filled it in. The 1 and the 5 is going to give us 6. The 5 and the 10 is going to give us 15. 10 and the 10 is going to give us 20. 10 and 5 gives us 15. 5 and 1 gives us 6. So now we've got this row. Okay. go ahead and fill in this row. It's the last one we're going to do. Okay, and hopefully you've done that now. So we got 7 here, 6 and 1 and 6 gives us 7, 6 and 15 gives us 21, 15 and 20 gives us 35, 20 and 15 gives us 35, 15 and 6 gives us 21, 6 and 1 gives us 7. It's clear that we could extend this forever. We'd spend the rest of our lives filling this in. Then we'd find that we made a mistake on the next row, and everything we did after that is invalid. But okay, so we probably don't want to spend the rest of our lives doing this. But this much of Pascal's triangle, and even a few more rows, can be very, very useful. And let me tell you why. Okay, not going to prove that it always happens, but let's just take the number, let's say C of 6, 4. Okay, number combinations of 4 things chosen from 6 without replacement. Order doesn't matter. Okay, so C of 6, 4, as we should know by now, is 6 factorial divided by 6 minus 4 factorial times 4 factorial. Okay, now we should all be able to simplify this, but just to be sure, I'm going to go ahead and write it out. 6 times 5 times 4 times 3 times 2 times 1. 6 minus 4 is 2. So, well, okay, I'm going to write out 2 factorial, 4 factorial, so we don't try to do too much at once. It means I'm going to have to write all these numbers again, but it won't hurt me. Okay, and then we have over 2 factorial, which is 2 times 1, multiplied by 4 times 3 times 2 times 1. Now I use the asterisk for multiplication here and dots for multiplication here. I could use asterisks for every multiplication. I could use dots for every multiplication. I chose to use a different symbol here just to separate the 2 times 1, which came from the 2 factorial, and the 4 times 3 times 2 times 1, which came from the 4 factorial. Now, 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1. We group these and we see that, well, we're going to be dividing this by this, and this is the same as this. When we divide this by this, we get 1. And then we're going to have 6 times 5 over 2 times 1, all multiplied by 1. Multiplying by 1 doesn't change the number. Now, people love to cross things out, but they do it wrong, and I don't really like it. But I'll kind of do it anyway. So these things go away. But they go away not because you get to cross things out. They go away because when you divide this by this, you get 1. And then when you multiply whatever you got over here by 1, you just get whatever you got over here. Okay. Now, 6 times 5 over 2 times 1 reduces down. 2 divides 6 3 times, and you have 5. So you end up with 3 times 5. Now, that's valid. If you want to cross this out and get a 3 here, just be sure you know why you're crossing them out. Understand what we mean by division and so forth. Okay, well, we go ahead and multiply that out. Now, many times, you know, I don't ask you to multiply this out. If you got, 14 numbers up here, yeah, I'm not going to ask you to multiply them out because the result won't mean anything. But when we've got only a couple numbers and the product is, say, up to 100, well, we can understand those numbers even up to 1,000. So we have some way of relating to the numbers. When the numbers get really big, we don't multiply them out. Okay. Now, the point here is we've calculated C of 6, 4, which is something you should certainly be able to do at the stage at which this has been assigned to my class. Now, if you're just seeing Pascal's triangle for the first time, well, you don't want to really use it unless you understand combinations. I'll say also that C of 6, 4 is 6C4. Okay, that's often written this way, and even in some places, this could be written C of 4, 6. Okay, you're going to have two numbers here. If one's bigger than the other, that's the one that goes on top. okay, and then it goes here, and then the smaller number goes here and here. But let's see what this has to do with Pascal's triangle. Okay, we've got 15. Do we see 15 anywhere on Pascal's triangle? Well, yeah, we see it here, and we see it here. And if we had enough of Pascal's triangle, we might see it in other places. For example, if we went down 8 more rows, we'd have a 1 and a 15 to start with. But these are the ones we want to see. Okay? Now, I want to make that connection, but I'm going to make it in a subsequent video. Okay, if you're still with us, the address at which you can find access to well over 2,500 videos, more than 300 hours, is http://vhmthphyd.vhcc.edu/vmenu.html. Videos covering all college transfer courses taught at my institution in mathematics and physics, including calculus-based engineering physics, up through multivariable vector calculus and introductory ordinary differential equations.